Hi, I just saw the previous video. We can collect numeric information from users using int and float to convert their text into a number. Now, we need to be able to do some calculations with them. There's some fairly simple ones, the addition, subtraction, multiplication and division. They're reasonably straightforward with a couple of little odds values in there. We'll do some little investigation into some of those. But there's also some fairly important additional commands that are useful. One particularly is ***, and that's because it's Dutch notation for doing something that we normally refer to as powers elsewhere. The Dutch deal with it as a mult, so they're dealing with it as multiply, which is why they've used that symbol in Python. But the other things that are going on here, we'll have a quick look and play with them as we go through. So let's go into a session, and we need some variables. Let's create a couple of integers. So let's go for bedtime. So, see again. Looks like I've got a refresh, so hold on a minute. Okay, ignore the bit at the top, it's probably not the program really either. So we'll just hide those out of the way and do some investigation. So let's say we've got some number of bricks. Bricks that are red. Now I can actually set that to be an integer value. And if I set them as 4, it will assume that that is an integer. I can be a little better and nicer for another programmer if I actually said int 4. That makes sure that when I print out brick red, I have got an integer number 4. The reason that's important is certain variable types may give me, let's look at the length of red bricks. Length of a red brick is, say, 5 centimetres. Now it could be a decimal number though, so if I print out the type of length of red, the length of the red brick is saying it's an integer. It's possible that I always want this to be a floating point number. I always want it to be a decimal, so the different lengths can come along. And a common way to do it is just to say it will be a float. That's nice for us to read as a programmer, because you can then see what variable is what. So say I've got 4 bricks and they're going to be put next to each other. How long are they? So I can do the calculation. Total length is the number of bricks that are red times the length of a red brick. And we would expect this to come out as 20. And we also will print out what type it is. So the total length has come out as 20, and it's a type of float. Now by default, when Python prints out something it knows to be a float, it will do it as a decimal number. So I don't need in future to keep doing this type thing to check what type it is. It will be there for me. So let's try doing bricks that are blue. And I've got 7 of them. So I can add bricks together. So I can put total bricks. And that's bricks red. That's bricks blue. And I can print out that total value. And this time we're adding 2 integer numbers together. We don't expect them to give us a decimal at any point, so Python has made it an integer value. Okay, it's worked it out for itself. The other commands, I'll just do some prints with sums So we've done an addition. If I do 12 minus 3, doesn't matter if actual numbers or am I using verbal, it's out, and that's come out as an integer one. If I do 12 minus 3 with a decimal on the end, the first number it knows is integer, second one it recognises as a float, and the result will be a float. Okay, so sometimes the output may be a little bit odd. We've done a multiplication with a star. Let's do a division. So 12 divided by 4. Both of those are integers. But notice the answer, it assumes, could be a decimal. So it's turned it into a float. Okay? So that's basically that, subtract, multiply, divide. I said there were a couple of extra ones. Now, if I do print 4 to the power, or it's the power, okay, it's the power, mult is 16. 4 to the power of 2, 16. I can do 4 to the power of 3 is 64. And one nice one is, if I do 4 to the power of 0.5, it will actually tell me square root of a number, which is handy to know. There is commands for square root, you have to import a library for it. If you're doing simple square roots, you can end up using star 0.5. I also showed you another number a minute ago where we did a print. If I do print 11//4, that's telling me the answer is 3. Well, the // implies it's something to do with division. So let's try a few numbers around there. This is what we mean by playing with a command. I'm trying a number of different values in the same area to see what happens and when things change. So what I've got here is I did 12//4 is 3, 13 is 3, 14 is 3, 15 is 3, but when I get to 16 I'll get the number 4. Now, if I print what's 15 divided by 4, it'll give us a clue. 3.75. The // is, it's doing an integer part of the division. But it's not quite as straightforward as that. If I do the 15//4 positive, it'll give me 3. If I do a negative one, most people will expect a -3, but it gives -4. It always rounds down. Okay? So just a little work, if you're doing negative numbers, it will always round down. And the last thing to do is something which is related to this. So let's use the 15//4 uses 3. And what's left does this percent mean? Well, it's got a slash in it, so it might have something to do with division. It says 15% 4 is 3. 15, let's try 14% 4. It's 2. 13% is 1. 12% 4 is 0. And when I go down to 11, notice playing with the command again, it goes back to 3. Oh, this is to do with the division. The percentage is what's the remainder, the modulus of a function. And that really is useful in computing because we often have to deal with things like 7 days in a week, making sure we're always clocking round in that time, or if you've got days in a month, you use the modulus to find out how many after the end of 1 month. Okay, so the modulus function is quite important. It's the remainder function.